I'm now delighted to introduce Dr. Cynthia Steele, Glaucoma Research Foundation's Chief Scientific Officer. Dr. Steele brings more than 2 decades of experience advancing innovative research in ophthalmology with a strong focus on translating scientific discovery into meaningful progress for patients. Her journey with Glaucoma Research Foundation spans over a decade, beginning as a Shaffer grant recipient, then as a dedicated industry partner, and most recently, as I mentioned, as our Chief Scientific Officer and Chair of our Research Committee. Throughout her career, she has been recognized for her collaborative leadership and ability to bridge science and industry to improve patient quality of life, skills that make her exceptionally well suited to help guide the next chapter of our research efforts. Ladies and gentlemen, please join me in warmly welcoming Dr. Cynthia Steele.
Really, I can't say enough that having this role, working with this foundation, is quite literally a dream come true. I originally was going to open with a photograph of myself in 2010 at my PhD graduation, but I showed it to Nancy, and she said, "Who's that?" So rather, I'll just tell you. The hair was different. But instead, I'll just tell you that I have a PhD in cell biology. I got it from Loyola University in Chicago, where I was one of the only people at the university who knew what a trabecular meshwork cell was and was interested in glaucoma. But I had every intention of staying in academia and starting a lab and getting R01 funding and the typical academic path. But thanks to my Shaffer grant in 2016, I found myself researching something that ended up being very closely related to something that was being developed, not to my knowledge, at Bausch & Lomb, and that's where I got my first medical science liaison job. And through that, I had a wonderful relationship with GRF, and eventually said, how can I help? I served on the research committee. And so when Nancy called and said, you know what we really need is we need a chief scientific officer, I mean, and it was a nanosecond. yes, please. I'm just so pleased, and I'm so proud to be here. This is just a dream. So thank you so much to Tom, to Nancy. Thank you. But especially thank you to the board, thank you, Andrew, and everyone here, and thank you, scientists and donors. Thank you for your trust. I don't take this responsibility lightly. So much of what we do is truly dedicated to curing glaucoma through innovative research, and that is an amazing responsibility, and I'm just so pleased and so honored to be able to play a part in this mission. So thank you very much. And now, let's talk about momentum and milestones. So I want you guys to just think back to when you were 18 years old. I'll give some of you some time. Yeah. Okay, are we there? Okay. So you're 18 years old and you graduated high school. Yeah. Woohoo. So what does a normal person do in the summer after graduating high school? Well, probably go on some trips, go to a few parties, hang out with your friends, make some really wonderful memories, and then you go to university. Well, in some cases, what could happen is you go on an amazing vacation with your grandmother, and she takes you to Rome, and she takes you to London, and see your family in Poland. But the whole time you're there, you're plagued with a strange headache that you can't quite shake. And when you get home, you go to the hospital and find out you have an IOP of 50. And then you go to university. And that is the story of Carolina Roble, who is actually a patient that I met at the patient summit last summer. Because someone came up to me and said, there's somebody else from Tampa here? And I said, get out, are you really? And she said, yeah, you should go meet her. So this is Carolina's story. She was a normal 18-year-old. Here she is in London in May. And here she is at Tampa General 1 month later. And she says that at just 18, she went from living a typical teenage life to having emergency combined cataract and trabeculectomy surgery 2 days after being diagnosed with juvenile open-angle glaucoma. From that moment on, her life was never the same. She had to learn to navigate a typical college life while also taking on this enormous responsibility of managing a chronic condition with her daily eye drops, constant follow-ups, and making really critical decisions about how she was going to preserve her remaining vision through research and potential clinical trials. Now, this would be overwhelming to anyone, but much less to somebody who's at such a young age. But today, Carolina's a junior at the University of Florida. She's majoring in poli-sci with a minor in disabilities and society, and she wants to be a disability rights attorney. And this summer, she's going to miss the Patient Summit because she's going to be serving as an advocacy intern on the American Council of the Blind, where she's going to be working on advancing accessibility and policy initiatives. And she's been selected to study abroad in London through the Innovation for Access program, where she's going to examine how the city has implemented inclusive design and accessibility practices for people with disabilities. Now, I asked Carolina what she wanted me to share with you about her story, and I have it written down here, but she said, I want people to recognize not just the medical side of glaucoma, but also the human side, the mental, emotional, and practical impact that it has on patients. And I hope it reinforces how important their work in advancing research, improving treatments, and ultimately finding a cure that can change the trajectory of someone's life the way mine was changed. And so for us at GRF, this is why we do it. And this is who we do it for. We do it for the patients. And our drive to innovate continues. Glaucoma is a multifactorial disease, as many of you know. Patients have a difficult time managing their treatments, not to mention the side effects. The disease mechanism is still poorly understood. Some patients have fear of surgery, can't blame them. And not to mention today's challenging funding environment. And to that point, I want to show you something. So I went to NIH Reporter, and I looked up glaucoma grants funded by the National Eye Institute since 2017. And then I went to Dimensions, where we can find all of our funded grants, and I did the same thing, looking at how many grants were funded by GRF in that same time. And I hope you can appreciate that there is roughly a 10% decrease in glaucoma-funded grants since 2021 by the National Eye Institute, but we've had a 45% increase since 2021. That's thanks to you. Thank you so much for that. Thank you. Thank you, David. And so how do we keep our momentum? We fund groundbreaking research, we promote collaboration, and we are working to make neuroprotective trials a reality. And to that effect, I want to share with you a few previous Shaffer grant milestones, because I think this is so important. In 1994 through 1998, 3 investigators, John Polanski, Julia Richards, and Tai Wynn, used their funds to discover the first glaucoma gene. It's called Tiger, but it's also called myocilin. In 2005 and 2011, Dr. Keith Martin got 2 Shaffer grants. He used those findings to fund his gene therapy company called Cuthera, which a couple of years ago was acquired by Astellas. Paul Lichter used his funds to study the genetics of 500 patients in the SIGIT study. In 2018, Monica Jablonski had created a novel drug formulation using her Shaffer grant, and she's used that formulation to launch Tavo Therapeutics, which actually I think presented at New Horizons a couple years ago. And most recently, Felipe Medeiros correlated biological age or epigenetic age with glaucoma risk. Not to mention, you have a few other Shaffer recipients in the room right now, many of which will tell you, I wasn't interested in glaucoma, but then I became interested thanks to funding from Glaucoma Research Foundation. And personally, as a Shaffer grant recipient myself, what I want to share with you is I want to echo what Carolina said in her statement, because it's not just about the money is wonderful, and we're so thankful for that. But there's something else to be said about having a foundation like GRF look at your idea without any pilot data, without any reason to fund you, and say, that's a good idea. We should try that. What that does for you, the wind that puts in your sails when you're a young investigator just looking for your big break, that cannot be underestimated. So speaking of which, these are the investigators that we're funding this year. And this is how we're investing in the future. And what we're doing here is I'm demonstrating to you what our strategic priorities are in the grants that we fund. So GRF is keenly interested in neuroprotection, regeneration, and enhancement, number one. What do I mean by that? Neuroprotection, of course, meaning we're going to literally protect a cell from dying in a stressful environment like it might in glaucoma. We're going to help them regenerate. So maybe the cell has started to die, or maybe it's losing its connection with the brain. We're going to try to regenerate that and make that connection real again. Or we can enhance it, so we can actually help that cell do its functions a little bit better, maybe make some more connections. And so you can see that these grants, there are 6 investigators in that category, including Dr. Shruti Patel, most generously funded by the Wilmoths, who are very interested in looking at neuroprotective strategies in glaucoma. We have immunology and glia, so we're very interested in inflammation and how maybe the inflammatory environment in glaucoma is contributing to cell death. Genetics and genomics. Arlene, I'm not sure where you're at, but Kate Keller thank you, hi Arlene. So generously funded Kate Keller at Oregon's Health and Sciences University, who is very interested in how cells in the outflow pathway, how their genetics differ in glaucoma patients versus healthy patients. And of course, IOP regulation and outflow. We're gonna have the first model of selective laser trabeculoplasty, which right now, when patients get SLT, the best that most doctors say is it energizes your outflow pathway somehow. With this money, hopefully, we will actually get a model of SLT and we'll be able to actually really figure out how that's lowering pressure in patients with glaucoma. So there are some really big questions that are going to be asked and going to be answered thanks to your generosity. But of course, as they say, if you want to go fast, go alone. If you want to go far, go together. And that's exactly what Catalyst for a Cure is all about. So this is a picture from our February 2026 Catalyst meeting. And I want to emphasize how rare this is. So what we have in this photo is we have the scientific advisory boards and the investigators from both CFC3 and CFC4, along with funders and members of the GRF staff. And we got them all together. And we've done this not once, but we've done this, 5 times now? It's been pretty remarkable to see the collaboration among everybody. So just to give you a little reminder, our Catalyst for a Cure initiative, the first one actually started in 2002. So if my math is right, that means that if the CFC1 was a baby, it would be probably finishing up its master's degree by now. It's that old. But it lasted for 10 years, and this redefined glaucoma as a neurodegenerative disease, which honestly is something that I thought everyone kind of knew. But back then, they were the first ones to really make that discovery, and that made a profound difference in how glaucoma was researched and how it's understood now. The biomarker initiative in CFC2 took place between 2012 and 2018. And then, of course, today we have CFC3, our Vision Restoration Initiative, and Dr. Jin Duan here. And also in 2022, we started CFC4, which is to prevent and cure neurodegeneration. So these are the CFC3 investigators. I think many of them are familiar faces to you by this point. So they're in their 3rd phase. And in this phase, they've gone from kind of figuring things out, and now they're done exploring in some ways. They're really on a one-track mind of how they're going to help with vision restoration, either by improving understanding of the sequence of events that happens that lead to glaucoma vision loss, or actually trying different small molecule therapies to actually force regeneration to take place. And so they are very, very close. Truly very, very close to finding vision restoration therapies. CFC4, or the Melza M. and Frank Theodore Barr Foundation Catalyst for a Cure initiative to prevent and cure neurodegeneration, took a different approach. because these 4 investigators come from different disciplines, including Alzheimer's and brain tumors. We have an information scientist, and we have a glaucoma specialist. And they are still in phase 2, so they're still very much in the discovery phase and figuring out how they can best collaborate with each other. And what they're learning right now is still pretty specific to their areas of interest, but they're starting to work together and see where the crossovers could be. So stay tuned to this initiative, because I think they have a lot more coming for them. But even the best discoveries go nowhere unless there's a path to commercialization. And so it's very charmingly called the Valley of Death. And what this is a gap between academia and industry. Because on the academia side, you've got researchers who have brilliant ideas, and they're very, very good at curing glaucoma in a petri dish. I can say that because I used to be one of those people. I was very good at curing glaucoma in a petri dish. However, no one's interested, as shockingly enough, no one's interested in that stuff by the time you get to the commercialization phase. And in the meantime, on the industry side, they have so many more experiments that they need to do that the university investigators simply do not know about. And so this area here is where a lot of good ideas just end up falling by the wayside. So we've created the treatment accelerator to literally bridge the gap. And so for the first time in medical history, there are multiple viable glaucoma treatments that could protect or restore vision. And these breakthroughs are real, but they get stalled before reaching patients. And so now the treatment accelerator is zeroing in exactly on this preclinical phase, this critical bridge between preclinical discovery and human trials. And this is the phase where the most promising treatments often fail, primarily because they don't receive funding. But by funding this very pivotal phase, we are aiming to deliver sight-saving therapies to patients much sooner. First example, of course, is Renervo. This came out of Dr. Yang Hu's lab, a CFC3 investigator, and as you know, championed by one David Schutt. And I want to show you just an example of what we're talking about here. So what I'm showing you, this is the only bit of science I'm going to show you tonight. What I'm showing you here, these red cells, these are retinal ganglion cells. Nice, healthy, stable retinal ganglion cells. But in a model of glaucoma, you can see that there's much, much less red, meaning there's far fewer cells in that glaucoma model. However, with the gene therapy that Dr. Hu is working on in his lab, you see all that red is back. That retina looks almost exactly like that healthy retina. And so this is one of the ways that we are working to actually restore vision back to patients that may have glaucoma, but now with this gene therapy, there is hope for a cure. So again, they're not just curing glaucoma in a petri dish. There is proof of concept studies happening right now. Their safety and toxicology studies are forthcoming, because of course a cure for glaucoma is no good if it's also not safe or toxic. We don't want that. And they're anticipating their first in human efficacy and safety studies will start taking place 1 year from now. So next year's annual dinner could be a celebration of a first in human trial. It would be amazing. Lastly, the other thing that we are doing and we've been working on for about the last 2 years is paving the way for new milestones, because a neuroprotective therapy is wonderful, but again, it's not going to go anywhere if it still costs hundreds of millions of dollars and will take 10 years to meet FDA standards for neuroprotection. So GRF, as part of its first treatment accelerator initiative, actually started designing new clinical trial endpoints for neuroprotection by forming a working group and funding this working group with Perceive Biotherapeutics and commissioning Felipe Medeiros to develop a new approach to make clinical trials smaller and far more efficient. And now, we recently funded the meeting from the Collaborative Community on Ophthalmic Innovation, or CCOI, where they're also starting to look to redefine glaucoma clinical trial endpoints in IOP, imaging, looking at visual fields, or quality of life measurements. Because again, we can have the best science and we can have the most collaborative work, and we can start to work on commercializing those therapies, but unless we get better endpoints, we're still going to be facing a massive uphill battle. And so actually, I think that puts GRF at the center of a really unique structure where we are imagine us at the hub of doctors and scientists and regulatory experts and industry professionals and VCs and everyone in between. But at the center of all of it are the patients. And we've included some patients here, including Carolina Roble, and I will also point out the handsome gentleman in the teal polo. That's my father. I am also the daughter of a glaucoma patient, and at his favorite restaurant, Olive Garden. I'm sure my mom hates it. but this is why we do it. The center of all of this innovation, yes, it helps, it benefits careers of researchers like myself, and it launches people's interest in glaucoma, but we will not stop until there is an actual cure that's tangible and available for patients with glaucoma. So with that, thank you very much.